Next up, we are really lucky to be joined all the way from New York City, Dan Reich, Chief Technology Officer at our very valued partner, Remesh, discussing human data versus synthetic data. Please give him a hand.
I'll try and, oh, here we go. Excellent, there we go. I tell the same joke every single time I get up and do one of these talks, and no one ever laughs. But I'm gonna do it anyway, and we'll just test it. I usually say, thank you so much for coming on time. I usually tell people that you can show up about an hour late to any AI conference, because we always spend the first hour trying to define intelligence. Okay, I got like 5, I'll take it. My name is Dan. I'm the CTO of Remesh. Is this? Nope. Which button do I press? Green? There we go. If you haven't heard of Remesh, we are basically a data collection and analysis platform. I'll sort of get into a little bit of what we do because it is relevant to synthetic data. About 6 months ago, I gave a talk about synthetic data, focusing specifically on synthetic persona generation, this idea of creating synthetic digital twins to kind of replace sample and all of that. No idea why Prolific let me talk about that, but they did, and enough to bring me back. So synthetic sample was the main focus, and when they said, hey, can you give the same talk again? And I said, no, I can't. We're way past that now. So things have changed drastically, but I'm still gonna use the context of synthetic sample to kind of go into talking a little bit about synthetic data, because I was initially going to talk about what is synthetic data, what are the types, what are the use cases, and then 2 weeks ago, this model that everyone's mentioned dropped, and all of a sudden people were like, oh yeah, synthetic data. Everyone uses synthetic data. So instead, we're going to build something today. We know now that synthetic or mixed data is an integral part of frontier AI, of AI applications. It's just kind of the way things are. We've been using it for years, but now it's much more in the public limelight, and generally you should use it too. But I quickly want to make a distinction between 2 types of synthetic data, and I'm gonna like completely obviate what I say in like 10 seconds. So we have synthetic data for training and synthetic data as output. So today we're sort of gonna talk about synthetic data as output, kind of the things we use synthetic data for. So put another way, we can think about it as synthetic data for machines and synthetic data for humans. In reality, they're kind of the same thing these days. There's tons of research showing that synthetic data is extremely useful for machine learning. It's been used for decades to reduce bias, reduce overfitting, tons of stuff like that. The notion of using large synthetic data sets has now, in the past 4 or 5 years, become increasingly important for training large language models. We're not necessarily running out of data, there's tons of data there, but the data that we have today is typically not in the right structure, not in the right format, doesn't cover the right topics or address the things we want. And so to get this tailored specific data is extremely hard. Why? Well, there are many reasons, and I'll talk about 3. Scale. As we sort of run out of the relevant data that we need, or we don't have it quite yet, or it's not easily accessible, we have a problem because data requirements are growing exponentially and sort of beyond what we can collect in a reasonable amount of time. But let's say we want to sidestep this, and the way we do that is we throw money at the problem. And that's kind of another issue, because looking at the scale of data sets we need, it becomes cost prohibitive very quickly. But let's say we solve this problem too. We have nearly infinite money. We still come up with another problem. How do we know we even have the right data? Is it biased? Is it not biased? We wind up in this cycle where we need an immense amount of data, we throw an immense amount of money at it, and if we're able to do that, now we have a bunch of questions to ask. Is 1, are you collecting this data ethically? Are you actually able to collect it quickly enough? And if you can, you're throwing money to get scale. You're now throwing more money to try and get the right content. You still need more data, so it scales. And then you're hitting this cycle where it just becomes really difficult to attain. So today I'm going to talk about one approach for generating guided, high-quality synthetic data in a way where we're going to build kind of a workflow to integrate it in near real time to constantly get a nice flow of data. And we're going to use what sort of was a new thing, but is old news. We're going to use an agentic approach to incorporate a steady stream of data into our applications. But we're going to start from the very beginning. Most things start like this. We want the answer to a question. So we ask a number of people a single question, or maybe we ask them 10 or 100, and we get answers. Maybe they're open-ended, maybe they're quantitative. This is a survey. This is typical data collection. If you've ever conducted a survey with open-ended responses, you'll get a lot of great qualitative data, things you didn't expect to see, but you wind up having to code this data, organize it. And if you discover a new topic, you're fairly limited in what you get and what you can do with it. I'm sure you all have read a study where out of the 100 participants, 18 mentioned waffles. Maybe not waffles, but what do you do with that? You now just have a 100-person data set, and now you have 18 elements that you can't really do a ton with. So this was the problem that Remesh thought of and we started coming up with. How do you sort of magnify the value of this qualitative data? And so the way we thought about this is, how can we get this qualitative data in a quantitative sense? And the way we thought about this is get participants to interact with this qualitative data. So you ask, say, 100 participants to respond to a prompt. You take all of those responses and ask everyone whether they agree, disagree, sort of rank the responses, and you wind up with a few data points which generally speak to agreement. How much do they agree with this response or that response? And the problem is, if you have 100 participants and you have, therefore, 100 responses, you wind up with 10,000 data points, which is awesome. That's a huge magnification. The problem is getting 100 people to answer a question 100 times and then getting them to look at 100 data points could take quite a long time. It goes back to the scale and cost problem. So our question was, okay, what can you collect in 2 minutes? Maybe it's 10 data points per participant. So if you do that, you wind up with something that kind of looks like this. This is very familiar to most of you. This is a sparse matrix. So you basically have agreement for every data point, and we want to fill this in. There are tons of techniques here. Happy to talk outside of this room about what our technique is and how we do things. But we can generally wave our hands and say we use AI magic to fill in the blanks. This is real data mixed with inferred data. This is a synthetic data set. This is a hybrid data set. It is synthetic data that is created from a subset of data which is real. You can do quite a bit of validation here, and we found out that it is actually pretty accurate. So, okay, great. Now we have basically quantitative data related to all of this qualitative data, but it's kind of low dimensional. It's these sort of bits of binary data, agree or disagree. These days, what we want is we want actually that qualitative depth. So how do we do that? It's effectively a zero-shot problem, right? We have 0 votes, 0 responses, and we want to fill in everything. So simplified, given X input, how would a human respond? Or more broadly, given no human, even outside the context of human opinion data, this is a fundamental problem. Given any prompt, be it a question, a decision, how do we respond when we have no direct underlying example of the intended behavior? But we do have a lot of data, a ton of data. But how can we use that data that may only be tangentially related to fill in the data we don't have? And this is a similar problem to the one we had before, but instead of these binary outputs, we're looking for qualitative ones. So 6 months ago, the approach I talked about primarily utilized prompting. And I'm going to kind of breeze through this, but happy to talk about it and answer any questions. We're just going to look at this as a baseline for generating some sort of synthetic-ish approach. And again, we're looking at this in the context of synthetic sample or synthetic personas. So here we have 2 Davids. Their names aren't actually David. But one of these Davids is a real person, data that I collected from a study from Prolific. The other is completely fabricated by a large language model. I did a few things here. We asked the real David, what makes a good piece of art? And he answered, originality. We then created a profile based on all of David's responses to the study we ran and sort of excluded the art question and asked this digital twin the same question and responded, a good piece of art is one that's original. That was pretty cool. We then asked the other David, the synthetic data, the same question, and they talked about something that tells a story or evokes an emotion. So we have three things here. We have real data, the real David's answers. We have augmented data, a persona based on the real David's answers, and purely synthetic data, an LLM-generated persona. If we look at the real David and the persona David, the results are very similar. I would argue that there's some trust here, whatever you want to define as trust. We know that it's based on reality. We can actually do some validation because we have real data points and we can do some comparison. We can measure to some extent how accurate this persona really is. The other David, totally synthetic. It's extremely hard to validate accuracy. You can sort of do it if you know how to do some sort of end token shenanigans, but way outside the scope of this conversation. So we have this sense if we're going to go synthetic, the best approach we can do to generate realistic or trustworthy data is to base it on real collected data. With that said, let's iterate really quickly, starting with something like our synthetic David into our augmented David. So this process is pretty straightforward. We start with a single prompt. We can chain prompts together. We implement underlying real data into our context, and then we can eventually fine-tune. We're going to blitz through this to talk about the more interesting stuff. So we start from the beginning. We start with a single prompt. So another random question here. What would an older millennial look for when purchasing toilet paper? You'd be surprised, but this is a very common type of question, especially in market research and other things like that. They want to know the answers to these questions. So maybe. This is kind of broad, but we want to get more specific. We want to increase the resolution here because practicality, environmental conscious, budget considerations, brand preferences, I can't do much with that. I can answer some broad questions, but I want to know more. So now we'll chain some prompts. And to get a higher resolution of data, one technique I use is a method of generative sampling. And we can do this by chaining prompts in some creative ways. So first, we're going to generate a bunch of millennials. Then we're going to ask them a question. And then we're going to summarize the responses. And we'll see what we get. So here are a couple profiles from some I generated from this experiment, purely synthetic. Pretty good. They seem realistic. They seem like they do things. The models have gotten a lot better at doing this. Had some interesting ones 6 months ago, but these are much more impressive. And some responses. One of the ones I like here is that Olivia, one of our personas, likes online brands like Who Gives a Crap. I looked this up. It's a real thing. I was very surprised, but kind of cool to see it here. So a summary. And let's compare this with the single prompt response. So this is a much higher resolution, very similar, but it gives us more to grab onto, more to think about, more to talk about, and honestly conduct further research on. So, but is this accurate? So we've created the fundamentals of our synthetic David, but we're in the dark about whether this is really accurate, and it's not even verifiable. So we're going to want to use real data. Now, depending on the data we have, we can use data augmentation to replace a variety of steps in a multiple prompt solution. Now, I'm going to warn you all, I'm terrible at making slides. You're about to see something, and it's going to get a lot worse from here on in. So We can insert real data into any part of the process here to facilitate the real data, right? We can just shove it into a single prompt. We can, as we saw, generate profiles from that real data, ask a bunch of questions, summarize them. We can do more chaining. There's a whole lot of different things we can do. And I warned you, but we're going to do something even more complex than any of these. So we are going to use underlying data to generate individual profiles within a demographic that we will individually ask questions to. We're going to converge on a single response and then converge on a single sentence to get a final survey response. So we're going to use data from a study I ran on Prolific, collecting data from about 200 participants, asking them about 40 to 50 questions to generate profiles. We're going to use those and use our own platform so we get a ton of data, we get agreement on all these different things, create these huge, big, unique profiles, and then ask them a question. So I asked them the art question. So I took all the profiles, summarized the art question from the real answers. I created profiles, and then I withheld that art question to create those profiles, and I asked the digital twins the art question as well. So on the left, we have the real response, and on the right, we have the profile digital twin response. And if I didn't tell you that, it would probably be hard to distinguish the two. But both mention evoking strong emotion, uniqueness, authenticity, personal connection, relevance, and there are some differences. The real data mentions art that makes them feel something, and the subjectivity of the work, while the synthetic data mentions aesthetic appeal and technical skill. So they're not exactly the same, but there are no real conflicting statements here, and there are far more commonalities than differences. And these results, though not perfect, are, I think, fairly impressive. And the cool thing is, because we collected so many data points, we can go through all of these withholding segments or individual ones and get a good range of how real is this? How valid can this be? And now we can start to make assumptions because we can actually build distributions and do a bunch of probability stuff and say something about our confidence. So the problem with this process, as you'll see, is there's a lot of prompting and we're chaining things together. And one of the risks we have is hallucination. And as you're chaining things and layering on top of one another, you're compounding potential errors in your hallucination. And you can drift from any perspective. And you wind up with biases, you magnify bad things, you hide good things. There's a lot of problems that can happen. And so one of the things you typically want to do is reduce the number of prompts you use. And this is where fine-tuning comes in. Fine-tuning is pretty hard, especially when you're trying to get this sort of amorphous qualitative data. Both from a technical and a resource data, you have to structure data very specifically. You need to do validation becomes incredibly important. I'm not going to go too deep onto this because honestly, I didn't fine-tune this data because it would have taken quite a long time. But generally, you can make that decision of if it is relevant to your product or what you're trying to do. It's absolutely worth fine-tuning your data just because generally you can say a lot more about validation and you can verify things. So all of this, lightning round, this is one way to generate synthetic data, thinking about the synthetic sample approach. So this is kind of where I ended things a few months ago. And this was more or less kind of what you could do, what people were doing, and how things were. Now, what we can take away from this is that absolutely you can get something realistic from purely synthetic data. You can get something useful, but in general, using underlying real data is kind of the way to go because you can say a little bit more, you can validate it, you can verify it, and you can still magnify things, right? We saw the 100 participants, 100 responses, 10,000 data points at LLMs, and you could change that into thousands, tens of thousands, hundreds of thousands. But that really isn't the end anymore. So we're way beyond this now, and if you're following along, you'll note that this whole process is fairly laborious. Even if we're using synthetic elements to the scale to solve the scale and content problems, there's still a lot of manual work involved with cost. So what can we do? Agents, agentic, these are words that are now in the common lexicon. 6 months ago, we started to see agentic frameworks coming out. but really things were starting to pick up. I would think that all of you have heard about agents or agentic systems or things like that. Everything I cover may be completely old news to you, but I have a couple points to make, and if you're familiar with agents, you'll notice that the things I talk about are not quite doable with current frameworks today, but there are ways to do them, and that's something we can talk about for sure. So with this, we can address scale, cost, and content, and that's huge. So going to talk about a few things. How can we refine our approach towards collecting real data? How can we simplify our approach to augmenting that data? And then how can we go a step further and dramatically improve the quality, quantity, and the nature of our data? First, let's get on the same page about agents. Very high level, really specific. I'm going to try not to use too many terms of art here, just really high level stuff. And this is sort of one example of a, quote, agentic loop. So we start with an instruction. We have some context. Maybe it's data. Maybe it's some details. We combine this with a list of capabilities. These are typically called tools. They're basically the things we can do. And we pass everything to an LLM. The LLM picks which of our tools are relevant to respond to the prompts. And we kind of now get what we're supposed to do. We do it. We take that output, combine it with the initial thing we're trying to do. We perhaps go to another LLM and we say, okay, am I done? Do I have what I need? If so, great, we return that output. If not, we craft a new instruction. We send it back to the beginning. So a little bit of a silly example here. Let's say we want to make a sandwich. Something near and dear to my heart. The context we have is nothing. We have nothing to start with. We have no sandwich or any of the component parts. We have a list of capabilities. We can get some bread, we can get some turkey, we can get some mayo, some cheese, what have you. So what we do is we say, I want a sandwich. I have no context. I pass it to the LLM. It looks at all the things we can do, and maybe it decides, okay, the first thing we're going to do is grab some bread. So now our context is we have a loaf of bread. I have a loaf of bread. I want to make a sandwich. Am I done? No. We go back to the beginning. I want to make a sandwich. I have bread. What do I do next? Maybe I get some turkey. Maybe I get some cheese. And we go on and so forth until I have a sandwich. If only it were this easy. So now let's look at one of our examples. In any of these examples, we are relying on collected data. You can see here. And before we can do anything synthetic, we need that real data. So let's go collect it in an agentic way. And we'll start by, imagine if you can, thinking like a human. Here's basically what we do. Start with a question, figure out who you want to talk to, create a survey, open a study, select demographics, start the study, end the study, index or organize your data. Obviously, very high level, but what we can do is now we can create tools for each of this steps. And it's going to get bad with the charts and the graphics again. I apologize. So these are pretty small. You can calibrate how big or small you want your tools. There is an advantage to having very small tools. I think I'll talk about that later. I don't remember. And as we go through this decision-making process, our agent will kind of create this path to getting to our solution. Here's a flow of how these tools might be executed. We can notice there's an opportunity to parallelize here, and we can do this through a multi-agent model. There are a lot of things we can do. Now, what's the advantage of having tools small? So I do talk about it. Well, what if we want to change things? And we want to add the specific questions that we ask to get demographics on Prolific. We actually want to duplicate that data, and we want that in our survey. We can literally just add 2 tools, and it'll slot right into the workflow. We don't have to change our decision-making. We don't have to change our architecture. We just add a couple new capabilities, and our agent will just do it. So let's look at this, the sort of overly complex augmentation architecture. And we're going to do the same thing. We'll create some tools from each step. I'm actually going to throw one extra in here. That's a little bit of a trick. And it's basically just a sort of a Boolean check to see if we have things, we don't have things. This lets us actually branch within our agentic system. So here's our new workflow, or here's our old workflow. Here's our new workflow. We didn't have to change the system. We just added some tools, and we kind of worked on. So the problem is I'm only getting survey data. We wanted more. We want some qualitative depth. So what's the gold standard typically in interview? Let's do an interview. Here's our list of things that we can do. Here's some tools. And now, I'm so sorry, but here's what we're looking at. So now we can kind of check if we have real data. Great, we'll use the real data. If we don't, we'll decide how much depth we want. We can go conduct an interview with a real person, or we can go run a survey. We come back, return that data. Great. But we don't really have a good way to create personas, which we wanted to do before. Again, we'll think like a human. And now here's the cool piece. We only need one tool this time. We have all the other tools that we need. We add this tool, and again, I apologize. We can use the same interview process to extract data from our persona. As we build things, we only have to build smaller pieces one at a time, and we can dramatically and exponentially increase our functionality. So you can even now ask things and use techniques that you never thought you wanted. If I said, I want a millennial to give me a recipe for avocado toast, this was designed to collect real data, but it will automatically make the decisions to saying, okay, do I have millennials? If not, I'm going to create a millennial. I want to think about recipes. I'm now going to interview a millennial with a single question, what's a good recipe for avocado toast? And it'll work. The idea of agents, of synthetic data, is all super powerful, but we have to make sure to be safe. One of the challenges with agents is we are using AI not just as an output for content, but to make decisions. And hallucinations with decision-making are extremely dangerous. They can have real human impact. They can cause harm. So we can actually create tools in this workflow that require a human to validate, that provide transparency, what have I done so far, that have stops and checks and validations for safety, that have guardrails and kill switches and everything else that you absolutely should use. But with that, I want to leave you with one last piece that is perhaps a little controversial, but interesting nonetheless. So what if our persona itself was an agent? We create robust profiles based on perhaps a long interview. We have data representing experiences, memories, values, relationships, what have you. And when we ask questions, we have tools to draw from these to answer our questions. Now let's add a human. And now maybe they have a conversation, or they're asked to make a decision, or they're asked to collaborate in some way. But now let's replace that human with another agent. You give them each differing political views and the instruction that they must agree on a topic, and you let them deliberate. You let them go for hours, maybe days, maybe weeks, until they come up with something. Now, what you come up with probably has zero interest to you. What's more interesting is what's the common ground? What are the differences? Where do they agree? Where are they motivated in ways that get them to this alignment? So I started this whole conversation talking about asking a question, trying to get understanding from an additional perspective. And if we are responsible and safe, we can end there too. So thank you so much.